I love that you just asked that. So I posted a message, I believe it was yesterday morning in Schoology. Posted like an update message. There's been 2 this week, one of which just straight up saying that 78% is fine on the unit test. The other one that came out first, and you guys can read, deals with the mastery update. So I'm about to start uploading grades into Schoology, or sorry, into MAP. I just wanted people to have a chance to, sorry, I wasn't screen sharing. I wanted people to have a chance to get their test back, but then we went back to remote, so that's why I hadn't posted grades yet. In Schoology, if you go to remote round 3, you will notice that there's now at the top here, Chapter 1, Progressing to Mastery, Chapter 2, Progressing to Mastery. There will also be a Chapter 3, Progressing to Mastery very shortly once I make it, like, alive. These are questions that I have created based off what we got wrong on the original mastery. Like, obviously, there's no answers here right now. They're all short answer essay questions. I will go in and answer your test. So, if in MAP, you end up with a progressing on a mastery assignment, you will come into our current folder and complete to the best of your ability, right? So don't rush through it. Don't make silly mistakes. You'll complete this for Chapter 1 if you're progressing, this for Chapter 2 if you're progressing, and I will post a Chapter 3 probably this evening. Also, this is going to turn into a YouTube video with me reviewing the entire original test. I need to finish doing that because it takes a little bit of time. So if you want help, like going over the original test, even though some of you don't have it back, like for Chapter 2 or Chapter 3, I have your test. But if you want to see it, you can go over it right there.
You just submit the answer, or?
Yeah, you like literally will type in the answers. So if I preview this, this is what it's going to look like for you. So like when you do assignments for other teachers in Schoology, it's going to look just the same as that. So when you go to take the test, first question, explain how we determine the sum of a positive and a negative. Feel free to use good guy, bad guy examples. So you just go through, you just type in the box. If there's words to type, you type words. If it's just numbers, you just type numbers. Does that make sense?
Yeah. Is this for the quizzes that we did, and the tests that we did in person?
Yes. So those grades, I don't know for your class if I have them in MAP yet or not, but I have them written down. I'm kind of old school, and I keep grades on a grade sheet. So guys, to show you how complicated this has been, and I'm not going to show you any grades, but if you look at my camera right now, I have like 8 different groups of kids split between blue and green and what class you guys come to me. I have grades written down on here. I need to put them in MAP though, because we're starting to talk about the next Discovery Day. And guys, we have foundations tomorrow, to make sure that you've heard that announcement a few times. We have foundations tomorrow. We're going to talk about the next Discovery Day. So please come to foundations tomorrow. It's not going to be club time. That did not work out. We realized that some advisors could not meet with their clubs, and that was silly to do club time when advisors couldn't meet with them. Any other general questions for everyone? Leah, I appreciate your festiveness. Bringing some holiday cheer.
You didn't even revise the questions you got wrong. You just
correct. We are shifting gears. So again, read my update, right? You guys can read. So go read my update, and that gives you all the details that you need. First thing I say is I'm sorry, right? Because we're having to change. We're having to pivot, if you know what it means to pivot. So first thing I do is apologize. Because what we were going to do is not working. Having people like take pictures and upload stuff, it's too complicated. So all you got to do is go complete the assignment in Schoology. So read this. Later, go read my update. Last week, or yesterday, quote unquote, if you will, the last time that we met in class, so these announcements you guys can read through on your own, right? Community Help Doc, please use it. We're in the final 2 weeks before winter break. Math Lab, please show up. Did we talk last week about 80% is now my Khan Academy expectation? Anyone able to tell me if we announced that? Yeah. So Khan Academy general practice activities are 80% now. So we talked about this, right, for rates, and more specific than rates, what type of rates are we mainly doing here? There's another word that goes in front of the word rate. Come on, somebody unmute and shout it out. Unit rate. Thank you very much. So the notes that you should have from the last time that we were together should talk about rate and unit rate, right? So rate is comparison between two values, whereas unit rate is where there's a 1 on the denominator. So we worked Emmanuel's problem to figure out he paid $2.25 per kilometer. And then I believe we did the pineapple juice, orange juice problem. Can somebody give me a thumbs up if we did talk about the pineapple juice, orange juice problem? Awesome. So then we talked about dresses, right? This was a weird one. Now, the thing I wanted to loop back on this problem and talk about, because I don't know if we said it, we got a unit rate of 16 21sts, or 16 over 21 dresses per 1 hour. We didn't write this the other day, so you might want to. That also could mean 16 dresses in 21 hours. Because if we say 16 21sts dresses in 1 hour, dresses per hour tells us dresses is on top and hours is on bottom. If we put it back to our original ratio form of dresses to hours. So if we ignore having 1 hour and say we don't care about 1 hour, it would be 16 dresses in 21 hours. Any questions on what we had done last time? Guys, please make sure that we're not multitasking. It's easy to tell when some of us aren't quite focused or like when we're getting going. Actually, everybody go ahead and hold up your graph paper, your notes, something. Show me what you got to work with today. Thank you. We're all good. Thank you very much. We're all good. All right. So now I think we made it this far. Did we talk about Harvey? This was probably the last problem that we did. The difficult thing with Harvey's question, and you guys maybe chose not to write it down, which if you did back then, you should write it down now. So the issue with Harvey's problem is it's a mixed number, right? So the problem with that mixed number is we need to make it an improper. So the first thing we did to Harvey's 3 1/6 kilometers is make it improper. What did we do on the bottom that's also written in the problem above? What do we use to turn a denominator into a 1 when we have a fraction in the denominator? The reciprocal. So we're going to practice this skill again, but with a problem for you to do on your own to start. So check it out. This one is your first problem for today. If we can travel 1/6 of the distance that we need to, like the distance between the two ports, in 3/7 of an hour, what is this if we do distance compared to time? So the first thing we should be setting up is what is the ratio that we want? So set up distance over time, right? Literally write the words distance over time or hours, right? Because they tell us we want 1 hour. There, now we can see both. Is anyone confused? Are there any questions on why I wrote distance on top and hours on bottom? Because I could flip this. I could put hours on top and distance on bottom. Why did we put hours on bottom? Who can remind us? Just unmute and shout it out. Why did we put hours on bottom? The problem
Because
at...
the hours are normally on the bottom, and the, like, for any problem, the hours are always on the bottom, because you're getting to 1.
Yeah, so both of those are true. Time is normally on the bottom, and they tell us we want 1 hour. So the fact that the problem says 1 hour, guys, that's why I wrote a 1 here and pointed to my denominator. When they tell us 1, that tells you what you want in the denominator. So if distance is on top, what do I put on top? What number goes there?
A 1/6.
1/6, right? The distance that we had was 1/6, and the time that we had was 3/7. sevenths. Ask yourself, what are we going to multiply by to turn the denominator into a 1? Now,
7.
yeah, further up in our notes, what we should have had written down from the last time we met is the word reciprocal. So we're thinking, what is the reciprocal of 3/7? Well, it's 7/3. I'm just going to go ahead and show the rest of the problem. That ends up, when we do the multiplication, giving us 7/18 on top. We get that 1 on bottom like we want. Guys, I can tell some of us aren't taking these notes, so I hope that that would be because you're already very comfortable with these problems. And that tells us 7/18 of the distance per 1 hour, right? Because we got to 1 on bottom. So that's when we can just say that in our label of per hour. Instead of writing divided by 1 hour, we just write the words per hour. Hello? Grant, I'm so sorry, man. Grant's been waiting in the waiting room because I did not notice because I got 3 screens and I just didn't look over that way. Sorry, man, for real. So this is the problem that we did. We set up fraction divided by fraction. We multiplied by the reciprocal in the denominator to get to a 1. We always want a 1 on bottom when we're dealing with a unit rate. Questions? All right, so now we got to talk about new stuff. So I would draw a squiggly line or get a new sheet of paper. Like maybe if you're near the bottom of your paper, just grab a new sheet of paper. I got to grab my little blocker thing. Sorry, I like using this because it's bigger. Please, on your paper, write down the fancy pants word, constant of proportionality. And then in parentheses, you can write that that's just a fancy way of saying unit rate. Constant of proportionality is a fancy way to say unit rate. I'm going to give you a second to write all of this, and then we'll talk about it. Guys, again, we're trusting you when we're on Zoom. But, like, if you choose to be off task, if you choose to be doing something else, you're going to pay the price for that. Right? Like, eventually when we take a mastery or, like, do practices, like, so please just focus on us. I'm going to try to get us out of here early today because our class is a little bit ahead. So now, some of this won't make sense, but I need you to write it down for now because it will make sense later. Right? So the constant of proportionality is the dependent change. And we start to use this triangle in science. Who can tell me what that triangle is? It's the Greek...
Delta?
Yeah, it's a Greek symbol. Delta means change. So it's the change in y when the independent changes by 1. So that's why it's our unit rate, because delta x is 1. The thing on bottom, we want to make a 1. And this only works for proportional relationships. Anyone know what a proportional relationship is? Harish?
So proportional relationship is when, so like if you have like 2 columns and each, like, and some of them have like a proportional relation, like, so if, one column is like multiplied by 3, like the whole time.
Now what do you mean multiplied by 3? You're right, but what do you mean? Wait, where'd you go, Harish? Why'd you stop talking? I was letting you be the teacher.
So like one column is like multiplied by 3, and then the other column is like multiplied by, I don't know, any number, 10 for example.
Yes. Now, hold on. You're getting a little bit more complicated than we want to just yet. What I thought you were saying, and what you're saying is true, but one way we can look for a proportional relationship is, like you said, times 3. If y is always times 3 of the x, so this would be a proportional relationship describing y is 3 times the x. The other thing you're talking about, Harish, is this sort of consistent growth. But be careful, that we would actually be looking for consistent addition. So we can do it two different ways. We can either multiply across from x to y. But you don't have to write this stuff down, guys. I just want to show you what we're talking about. Here's what I want you to write down. I'm gonna give you a minute because there's also a graph to draw. The red line over here is not proportional. So please write down everything I have below proportional relationship here. Trust me, it will help you in the future.
Can you go up a little? Okay. Thank you.
You are welcome. Thank you. That it looks like pretty much all of us, I think, are just taking down the notes. That or you're doing a really good fake and you're pulling one over on me. But if so, that's your choice. Guys, I'm serious. Like, even at this point in the year, you're not too deep to like change habits. So if you realize that you've gotten in some bad habits, change them now. Don't wait till years from now. You're like, oh yeah, that year when we had the pandemic, that's when school started to get really tough for me because I didn't pay attention in class. I didn't take notes. I didn't like, don't do that. Don't make this the year that school got tough. Like, double down, right? Put in lots of effort. I am going to scooch up a tiny bit here because we got a little bit more to write down. These are all examples of what proportional relationships are going to potentially look like in Khan Academy when we see them. All it's gonna, like, what we're gonna see when we talk about an equation of a proportional is y is equal to some number times x. It doesn't matter if we call that number r or m or k or hashtag whatever. It does not matter what variable they use for the constant of proportionality. A lot of people use k, but Khan Academy seems to like r, because actually our constant of proportionality is a rate. So this is why Khan Academy uses r, but we can use m, we can use k, we can use whatever we want. Any questions on what we've written down here? Clark?
I'm just having a hard time understanding like any of this. Can I just talk to you after class?
Absolutely. We also have extensions today, right? So here's what we're talking about. Maybe this will help. If you go get a job raking leaves, let's say that I pay you, because I got a bunch of leaves in my yard. I got a giant willow tree. If I pay you $5 per bag of leaves, So I'm going to pay Clark $5 per bag of leaves. Now you got to fill it all the way. I was about to say, you got to fill it all the way up, though. No, like half-full bags. We could say the pay that you will be getting is 5 times the number of, bags. This is the same as saying y equals 5x, right? It doesn't matter what variables we actually use. We can change the letters, and it's still the same situation. So, Clark, to figure out your pay, we can plug in any number of bag of leaves. Before you start working, you have 0 bags of leaves. How much would I owe you? Nothing. Right? That is the origin point. That is why a proportional relationship uses the origin, is if you don't do anything, you don't get anything. Now, if Clark rakes for a while and gets 3 bags of leaves, what do I owe him now? $15. What if you rake all night long and, like I did the other day, you end up with 18 bags full of leaves? I'm not joking. I had 18 bags down at my curb.
That's $3.90?
Ooh. 50 plus 4. Yeah, it's 90. Right? So then I would owe you $90. Ooh, Clark, you're rolling in it. You're getting lots of money. Now, I already raked most of my leaves, so sorry, this offer is not on the table. But does that make a little bit more sense of, to start, we have a 0 point, because if you don't do anything, I don't pay you anything, and then we go up. You'll earn more money as you rake more leaves. So, you can if you want. That's up to you. I'll stick it right here for a second if you want.
One more question.
Yeah.
Since the line is it's in the negatives too.
So, sometimes we ignore this part of the line. It exists because mathematically we can look back in time, like quote unquote, but we can't actually, right? Like, so Clark can't bag a negative amount of leaves. Like, Clark shows up at my house and he dumps leaves on my yard. Like, that wouldn't make sense. Now, Clark, I would be very mad if you show up at my house and dump leaves on my yard. But, like, mathematically, we can keep drawing the line, but all that we would actually look at is the positives, right? Like, we would only look at this part of the graph for the positives. Those are great questions. Keep them coming in. Other questions that we got, people? All right, I need to send attendance now. So let's see what... yeah, we just talked about this. It should be on your notes. If the input is 0, the output is 0. And KX or MX or RX or whatever. So the next thing that we need to write down that is actually very important, if any of these, if this is what we're using, if y equals r times x, and we try to isolate r, right, get r by itself, get r by itself, we divide by x, so r would be y divided by x. And guys, this is true whether it's r or k or m. Guys, this is what messes people up. It's y on top, x on bottom. I literally just today was helping a Math 8 student, like 8th grade math, who had this flipped upside down, and he was getting every single question wrong, right? Because this was flipped upside down. So please write down whether it's K or M or R, doesn't matter what it is, we put the y over the x. So for example, look at this graph. Ask yourself, does it go through the origin? Does it go through the 0 point?
Yeah.
Yes, it goes through the 0 point, right here. And then, now this is where we have to be careful. Is this xy or yx? What's the order of our point?
XY.
It's xy. It's the x first, right? So when we go to write this down, and please copy this down then, please make a note on your paper that this is xy. Please remind yourself of that. It's easy to forget that. So then we put the y value over the x value. Our y value was 2. But guys, this is why you're going to screw up. The 3 comes first, and you're going to want to put that on top. That's not how it goes. The 2 goes on top, the 3 goes on bottom. Questions on that? Sorry, I'm trying to send attendance, and multitasking is hard. Hudson?
Yeah.
Howdy.
I don't get the ones in blue, the letters in blue.
Yeah, let's do another one. So thank you for speaking up and asking that. This is brand new, right? We've never done this before. So as long as you have this written down, we're going to do another one, and it will all start to make sense very soon. So thank you for saying that. If this was the end of my lesson, I'd be real worried. But we're still in the thick of it. We're in the middle. So any proportional relationship, if we go back and double check what we wrote down, uses the origin. It has the 0, 0 point, and it should look like a straight line, right? No curves, no wiggles, no squigglies, no anything like that. So if we look at lines like A, B, and C, all of these are proportional. Because if I can get my little Google thing to drop away, actually I'm just going to do this so you guys can see it easier. Notice how they all use the origin point. They all like start down here at 0, 0. Now, the other thing that we talk about with lines that are proportional, or even just lines that are linear, is every line has a slope. Hey guys, please make sure that we're focused. I just had to unmute somebody because it sounds like had to mute somebody because it sounds like there's music at your house, which is great. I love music, but it might be distracting. So please make sure you're focusing on what we're doing in math class. Please, please, please. Especially because this is new, right? This is tough. So guys, if we look at lines A, B, and C, I want you to see that this picture is from this. Okay, so stick with me because I can't write on here like I can normally write on my smartboard. So check it out. If I look at where I can find a point for A, it's tough because there's not a good point. That's like halfway through the box. Not a good point, not a good point, not a good point. Ooh, right here looks like a decent point on line A. Does anyone have questions on me picking that point for A? Because it is where our line goes through what's it called? Crosshatch? Crosshatching? I think something like that. It's the intersection of X and Y, like whole numbers. Right? That's going to be whole numbers right there. So then we have to ask ourselves, what is that point? Well, it's 2, 5. Because if I count on my x-axis, I go over 2, and I go up 5. Remember that my horizontal axis is my x-axis. My vertical axis is my y-axis. So I would write down the point 2, 5 on your paper. Sonny, what's up?
I heard you say about A, B, and C, and something about A. Could you say that again?
Yeah, we're looking only at line A right now. So I'm going to label my notes page so we can remember what we were doing in this moment. I'm going to label this lines A, B, and C. I'm literally just going to write down lines A, B, and C. For line A is actually our blue line, so I'm going to switch colors. So let's say line A has point. We said that point is at 2, 5. Now, guys, I need you to speak up if you have questions. Please ask if you don't know how we got that this is 2, 5. We count over on the x-axis for our first number. We count up on the y-axis for the second number. So at this point, we've gone over to the right 2 boxes, and we've come up from the bottom 5 boxes. That's how we get 2, 5. Then K or R or whatever we want to call it, the constant of proportionality, which we oftentimes call K, is the Y number over the X number. So we literally just put the 5 over the 2, and that's it. That is our K. Making the resulting equation Y equals that constant of proportionality, 5 halves over X. So I want you to try that with line B. I'm not going to move my screen. I'm not going to show you anything else because obviously where that arrow points, where this arrow points is going to tell you the K. But I want you to figure out what's the K for line B and what does that then make the equation. So if I was you, I would write down line B has point, and they tell us. So take a moment, try that out on your own. All right, anyone want to volunteer to tell me? Ooh, hold on, we're still on B. If line B has 0.45, Nason, can you tell me what the K becomes here then? The constant of proportionality?
5/4.
Yeah, the Y value over the X value, so it's 5/4. So then the equation for line B would be Y equals...
Y equals numerator.
5/4. What? Yes. Proportional relationship lines are always going to be Y equals some number X, which we wrote down on the previous page. At least for me, it's the previous page of notes. You know I'm going to make you do the purple line on your own, so you guys tell me what questions do you have, right? Like, try the purple line on your own. If you can't figure it out, you should ask me a question. So what you're looking for... Yeah, sorry, I'll show you my notes again. There you go. You should be able to see a point on the purple line that you can use. Now, Nason already kind of said it. Can somebody else who's not Nason tell me the point that Nason had said that we can use? Not very good, not very good, not very good. This looks good. What point is this?
2/4.
Ooh, careful. How far over on the X? This is dangerous because I cut off the picture. That's not 2. That's actually 4. So be careful, guys. Every tick mark here is worth 2. Every tick mark here is worth 2. So 1, 2, 3, 4. And then the y value, how far up have we gone?
1.
1. Meaning that our k here will be what?
4.
Yeah, 1 over 4, not 4 over 1. Right? So be careful. It's the y over the x. You can even label above this if you want to help you remember. Meaning the equation becomes y equals that constant of proportionality times x. Questions on that? Because I'm going to ask you to do it again on another one. All right, I will show my notes again. Like, I'll keep my notes showing. Be careful here. Check the scale, check the numbers, check the situation that we have here. What is the equation of the line showing over here now? Let's just go ahead and call this line D, right? We might as well. Ooh, that might be the point. So if you're paying attention to the chat, Clark just told us line D has point what? 1, 3. Right? Line D has point 1, 3. Now, the other thing that we could say, if we want to go back up here, is that all of them, all of these lines at least, use the 0, 0, right? So that was the other thing that we said was important, that we have the 0, 0. So that's good. We got it, right? So we use the 0, 0 on all of these lines. We still do on line D, what I'm writing in brown now. So that means what's k in this situation? Is it 3 over 1 or 1 over 3?
1 over 3.
Ooh, trapdoor! It's 3 over 1. Remember, the x is on bottom, the y is on top. Meaning the equation becomes y... No, wait. Can I simplify 3 over 1? Do I have to put the 1 on bottom?
Oh, you could just write 3?
Yeah, we could just write 3. Another name for the constant of proportionality, and this is where I'm going to wrap up class today. Another name that we can use. Yeah, but there's another one. You guys know that AKA means also known as. Sorry, so if you didn't know, AKA means also known as. This is also known as the slope of the line. Now, one of my favorite math websites ever is called Desmos. We've used Desmos this year, right? But we've used it for activities. If you go to Desmos, you can just literally click on their button that says Graphing Calculator, and we could graph all the lines that we just graphed today. Y equals 5/4 x. This was our green line, right? Y equals 1/4 x. This was our purple line, right? Y equals 5 halves x. This was our blue line, right? We could compare all of these lines and put them all on the same graph. Guys, here's the last thing I want to leave you with. Everything can reference back to y equals 1x, which is the line that would perfectly cut through each point, right? 1, 1, 2, 2, 3, 3, 4, 4. Now, those aren't true because I need to zoom out, right? So if I zoom out a little bit, Even more, because my scale needs to fix itself. There we go. Now my boxes are 1. Right, so guys, this point would be 1, 1. This point would be 2, 2 if I'm actually on the line. This point would be 3, 3. My x and my y are always going to be equal. So a slope of 1 is like a 45-degree angle, if you've ever done much with angles. So I am going to mark our slides with the fact that this is how far we all made it in this class. And that is going to wrap us up for today. So I do need to ask Valerie and Megan to hang out just because, as I'm sure our other Phoenix peeps know, you guys are newer to Phoenix. So I got to make sure that we're all on the same page and in the Khan Academy class and everything. So if you're not Valerie or Megan, unless you have a question, you are free to go take a break before your final class of the day. Remember, there's extensions today. If you need math help, come to extensions. Bye-bye.
Thank you.
Thank you. You guys